Okay, so hi everyone. So welcome back to this new video in the segmentary series. So today in this video we will be discussing about this interesting problem that goes by the name enemy is weak, and it was asked in Codeforces beta round 57 div 2, and this problem is rated 1900. Okay, and before starting reading this problem, let me tell you all that this problem will utilize the concept that we have discussed in the first lecture of this series. So this is the video that I am talking about. So still, if you have not watched this video, please go back to this video, understand the concept, and then come back to this video, right? Then you will understand much more better, right? And also, if you have not subscribed to this channel, please subscribe this channel. As you can see that I am regularly uploading very good quality problems. As you can see, in this way only I'll be uploading more and more videos in the upcoming days as much as possible from my side. So that's why if you have not subscribed to this channel, please subscribe the channel, right? So, and we are pretty close to 500 subs, so please subscribe. And so let us come back to the topic now. So the problem reads like this: the Romans have attacked again. This time they are much more than the Persians, but Shapur is ready to defeat them. He says a lion is never afraid of 100 sheep. So you can ignore this line at all. Nevertheless, Shapur has to find a weakness in the Roman army to defeat them, so he gives the army a weakness number. So you can also ignore this line, this is not of much significance. So in the Shapur's opinion, the weakness of an army is equal to the number of triplets, that is I, j and k, such that I is less than j and j is less than k, and a of I is greater than a of j and it is greater than a of k, where a of x is the power of the man standing at the position x. And the Roman army has one special trait: the powers of all the people are distinct. So help Shapur find out how weak the Romans are. So in the input we will just be given an integer n that can go up till 1 is 6, and which will represent the number of men in the Roman army, that is the size of the array, and then will be given the array, that is the powers of the men in the Roman army. So in the output we have to determine the weakness of the Roman army, that is the weakness of the given arrays, right? The problem is quite straightforward if you see. That is, we will just be given an array every time, and for every array we just want to determine the number of triplets, that is ijk, which satisfies these two conditions simultaneously, right? So if you look in the first example, let me zoom this a bit. So as you can see that in this array it consists of 3 positive integers, right? So tell me, how many triplets can be made out of this following array? So exactly one triplet can be made, right? Because only 3 elements are present. You cannot make more than one triplet. So this will be the only triplet. That is, the 0th based index will be my ith index, the 1th index will be my jth index, and the second index will be my kth index. So I, j and k representing these 3 indexes, and this will be the only possible triplet. So if we look in this triplet, then what we wanted to perform? We wanted to see that if it satisfies these two conditions. The first condition is that I should be less than j and j should be less than k. So here clearly the 0th index is less than the first index and the first index is less than the second index. So there is no problem in the first condition, right? But the second condition was magnitude of these elements should be in this order. That is, the smallest index of all of these three should have the greatest value and it should decrease while going forward. So if you look here, then what I just told you, I told you that the smallest index out of the I, j and k, that is the ith index, which is our 0th index here, that has a value of 3, should have the greatest value, and it has a value of 3, right? And what we wanted then, we wanted that when we move forward in this I, j and k, then the value should decrease. So here if we move forward, then the value is clearly decreasing. As you can see, it is 3 and then it is 2 and then it is 1. So it means that this triplet is satisfying the given two conditions. And since this triplet is satisfying the given two conditions, I can say I have a total of one triplet which satisfies this given condition in the question, and therefore the output is 1. Similarly, if you look in this input, that also consists of 3 integers, right? So only one triplet is possible, right? That is 0, 1 and 2. So the 0th index is 2, first index is 3 and the second index is 1. So this only triplet is possible. Clearly the 0th index is less than the first index and the first index is less than the second index. So the first condition is satisfied already, but the second condition will not be satisfied here. Why? Because what we wanted that if this is a triplet, then the smallest index of this triplet, which is this here, should have the greatest value and it should decrease while going forward. But if we go forward here, then clearly from moving from the 0th index to the first index, the value is increasing. But we don't want that. We always want the value to be decreased as given in the question, as specified in the question, right? So that's why the number of triplets that satisfy this property in this input is 0. So that's why the output is 0. Now let us look at this input. So in this input we are given a total of 4 integers, right? So now since we are given a total of 4 integers, that means that the number of triplets that is possible now with this array will not be 1 anymore. Because how many triplets are possible now? If you see, then we can take this 10, 8 and 3, this 10, 8 and 1, 10 and 3, 1, this 8 and 3, 1. So a total of 4 triplets are possible here. So I think I should explain you about this input in the blackboard itself. So let us now go to the blackboard and understand how the output is for this input. This was the example that I was talking about. So we are given these 4 integers, right? And I told you that in this array there will be more than one triplet possible. So what are these triplets? As I told you, so let me write all the triplets here. Let me also give the indexing here. So these are the 4 triplets out of the given array, and I have marked the indexing also for all of these 4. So now if you see, then let us start checking each triplet one by one if they satisfy the given conditions or not. So what was our given condition, if you remember? So our condition was that our I should be less than j and our j should be less than k, and the value of the ith element should be greater than the jth element, and it should be greater than the kth element, right? So these are the 2 conditions that we want to satisfy for each of the triplets. So this is our first triplet, and clearly 0 is less than 1 and it is less than 2. So this condition is satisfied. But if you look in the second condition, so we want the element's value to decrease when we move forward, right? Because this is the greatest and this is the smallest. So the value should decrease. So here if you see, then 10 is the largest, and then we get 8 and then we get 3. So the value is decreasing. So this is also satisfied. So since both the conditions are now satisfied for this triplet, we can say that we can add +1 to our answer. That is, by now we have got one triplet that satisfies these both properties. Now let us check for this second triplet. So for this triplet also, if you see, then 0 is less than 1 and 1 is less than 3. So the first condition is satisfied. And also if you move in this direction, then 10 is the greatest and 1 is the smallest, and the value is decreasing when going in this direction. So this triplet is also satisfying the property. So what we will do, we will again increase the count. And now if we check for this triplet, then 0 is less than 2 and 2 is less than 3. So this condition is satisfied. And also if you move in this direction, then 10 is the greatest and 1 is the smallest. So the value is decreasing. It means that this condition is also satisfied. So that's why I can say we will again increase our count by 1. And if you look at the last triplet now, so clearly 1 is less than 2 and 2 is less than 3. So this is satisfied. And the element's value when going in this direction, it is decreasing. First we get 8, then 3, then 1. So it is decreasing clearly. And since it is decreasing, we can say this condition is also satisfied, thereby increasing our count by 1. So a total of +4 here, right? So what we did, out of the given array, we wrote all the possible triplets and checked one by one if they satisfy both of these properties. And if they do so, then we just increase the count 1 each time. And whatever the final count we got, this is our answer. And the output for this example is also 4. So I hope you have understood this example very well, and also what this question is asking us to print. And then this is our last example given in the question. So if you look in this example, then again 4 triplets will be possible, just like we did for this array, right? So again here 4 triplets will be possible, but the only triplet that will satisfy the given conditions will be this triplet, that is 5, 4 and 3. Because clearly the index is increasing while moving in this direction, but the element's value is decreasing. So that's why this is the only triplet that will satisfy this question. You can check by dry running, right? And that's why the output is 1 for this. So I hope you have got the concept of every example, how the outputs are coming for each of the examples, and what this question is asking us to print. So the question is not asking us very hard things to do. It just wants us to check for every triplet this condition, and if it is true, we just have to increase the count. So now the question is how we will perform this. So as I told you that I have discussed this concept of inversion count here in the first video of this series, right? So let me quickly give you a recap of what we did in this video in the blackboard. So suppose this is our given array. In that video I have explained you that I want to find the number of pairs, right? So I want to find the number of pairs, that is ij, that satisfies this property. That is, I should be less than j plus the value of a of I should be greater than the value of a of j, right? So if it satisfies these two conditions, then I will increase the count by 1 here. So the same thing I have explained that in that question also, right? So what we used to do, if you remember, so we used to take the maximum element of the given array, so here 5. Then what we used to do is we just create another array and make sure that we can reach the 5th index. So I make sure that I can reach the 5th index very easily. So here if I draw, then it would be something like this. So after we have constructed this array by taking the maximum value from this original array, what we used to do, that we used to start traversing these indexes from the 0th, that is from the very start, one by one. If we are suppose at the second index, then we want to determine how many indexes are previously present, that is in this range, that are greater than 2, right? If you remember, then what we used to do next, suppose we have started our iteration from the 0th index, then we say that we are encountering this 5th for the first time, right? And also the initial value of each of these elements are 0 in this array. Keep this in mind, right? So whenever we move forward in this direction, right? So since we encountered this 5 for the first time, then what we used to do, we simply increase its count. So we used to say that I will increase the count of this 5 by 1. So this is the status of the array when I reach the first index. That is, the value of the elements in this array represents how many times I have encountered that index, that is that element, when moving forward in this direction, right? So since I am currently present at 1, it means that I have only encountered 5 one time, which is obvious from here. So we want to find the number of elements greater than this 4 that we have encountered while we reach this 4, that is on this range, right? So what we used to do, since we want to take the elements greater than 4, that is greater than or equal to 5, so we used to take the range sum starting from greater than or equal to 5, right? That is, so we will take this range only, and we just used to compute this range sum. And what does this range sum represents? This range sum used to represent the number of times, that is the number of elements that is greater than this 4 and have occurred in the past. So that's why we used to fill this array one by one as we move forward. So this is the thing that we used to print in the first video of this series, right? So I made a very quick recap of what we actually used to do in that question. So now let us come to this question back. As you can see here that this question is very much similar to the previous problem. In the previous problem, we used to find number of just pairs, that is a pair of two elements which satisfy this property, that is I is less than j and a of I is greater than a of j. But in this question, the number of elements is increased by 1. That is, now we want to find the number of triplets which satisfy these properties, right? So the question is exactly same, but the thing is, now we want to count this number of triplets. That is, we don't want to find the answer for each index, rather we want to add the answer for each of these indexes. So what will be our logic? Let's see. So as I just explained you this inversion count concept very quickly. So what we did, for each index we just calculated how many indexes, or rather how many elements are present on its left side, that is this range, which are greater than 2, right? So keep this word in your mind. So we found the greater elements on its left side, don't we? That is, for each index we found the number of greater elements on its left side. But suppose the question if had asked to find instead the number of smaller elements on its left, then what we have done in that case? So since it had asked greater here, so suppose we were standing at this index and the value was 2, so we wanted greater than 2, that is greater than or equal to 3, so we used to look in this range. But if the question has asked to count the number of elements which are smaller instead on its left, now what I'm saying, tell me the number of smaller on its left, then what could you have done? So we will again do the same thing only, but instead of starting from this 3 to 5, we will simply start from this 0 and we'll go till this one, right? So since in this case we wanted to greater than 2, that is greater than or equal to 3, so we took this range. But now since we want to find the number of elements smaller and present on its left side, so I will simply start from the beginning and we'll go till one less what we want to compute. So this is common sense, right? We wanted greater, so we took this range, and now since we want smaller, we will simply take the range sum of this, right? And in this way I will get these two. So this is easy, right? So let me erase this. So let me again tell you what I just said. I told you that in that question we used to find the number of elements greater on the left of it. So if we were standing at this index, we wanted to find the number of elements greater than 2, that is greater than or equal to 3, that have occurred in this range. So we used to take the range sum of this, right? But if we wanted to find the number of elements which are smaller than it and occurred on the left side, then we will simply take this range sum instead of this, right? So this thing is clear by now, I guess. And I will again say the same thing here, that is, I will again want to compute this greater and this smaller, but now for the right side. That is, I want you to answer for each index how many elements are greater on its right side and how many elements are smaller on its right side. So again, some of you might have predicted and guessed what we will do. So instead of starting from the very start and going in this direction like this, in order to compute these two, we will simply reverse our process. That is, we will now start from this direction and we'll go in this direction like this. So as we move forward in this direction, we used to update the status of these elements, right? And whenever we were present at some particular index, if we want to determine the number of elements greater than itself that have occurred in this range, then we will simply take the range sum of that range, right? And it will give this result correctly. And similarly, if you want to compute the number of elements which are smaller than these two and occurred in the right side, then we will simply take the range sum in this range and it will give this output. So these two are the exactly same as these two. We just have to reverse the process. So before we were moving in this direction and updating the status one by one like this, and thus getting these two. But now what I am telling you is to move in this direction instead. So instead of getting this left, we will get these two right, that is the greater on the right and the smaller on the right for each index as we move forward in this direction. So once you have understood these, you must be wondering how we will use this concept here in this problem. So this problem will utilize this exactly same thing that I just told you. So whatever I am going to say now, just listen carefully. So I am saying that we want this to be satisfied, right? That is, a of I should be greater than a of j and this a of j should be greater than a of k. For this condition, these four were our possible examples, right? So let me write one of them here. This 10, 8, 3 is one of the possibilities which will satisfy this condition. So just tell me one thing, that if I keep this 8 fixed, that is, I will not touch this 8, right? And if I change these two, that is, if I change this 10 to something like 11 and then also change this 3 to something like let's say 2. By doing this, that is keeping this as it is and changing these two, is this property still valid? So yes, this is still valid because this is the greatest, this is the smallest, and this is decreasing in this direction. So these two conditions are still valid here. So now I have given you the permission to change these two values, that is the ith index and the kth index, while keeping this jth index intact, right? That is, we don't have to change this, we just have to change this. And we saw that earlier this is our one of the possible result which satisfied this condition, and now this is another possible result and this is also satisfying this condition. Similarly, suppose by keeping this 8 fixed, I changed this 11 to something like, let's say 9, and this 2 to something like 7. So is my property still valid for this triplet? So the answer is yes, because the magnitude is clearly decreasing while going this way. So what I am trying to say is, you just have to keep this jth index fixed, and you can select this ith and kth index value in such a way that this ith will always be greater than this jth index and this kth index will always be smaller than this jth index, right? So if you are able to make these triplets like this, right, so whatever value you will get, it will always satisfy this. So since initially this was satisfying this property and I wanted to satisfy it for another triplets, so I just keep this fixed and kept on changing these two values and made sure that the left value is greater than this middle value and the right value is smaller. So now assume that I am talking about this array. So I have considered this myself, and we want to compute the number of triplets such that my I will be present in this range, my k will be present in this range, and I will mark this 3 here as my jth index, and I will not change this, right? If I do this, then I can say I want this to happen, right? That is, some element present in this range in the ith index which will be greater than this 8, and some kth index present in this range which will be smaller than this, right? So how many such triplets are possible? That is, I want you to fill these two spaces in such a way that it satisfies the given condition, that is this condition. So I want to fill this with some element greater than 8 of this range. So if you see, then we can fill this circle with either the second index element, or either with the first index element, or either with the 0th index element. That is, either with 9 or with 10 or with 11, because these three are actually greater than this 8, right? So how many choices did I have to fill in this circle? So let me write that here. I actually have 3 choices, right? And in the same way, how many choices did we have to fill this circle? That is, number of elements less than 8 in this range. So since this 7 is less than 8, this 3 is less than 8, this 2 is less than 8, and this 1 is less than 8. So clearly all of these 4 elements are less than 8. So it means that we can fill these circles with any of these 4 values. And now let me write those values here also so that you can understand better. So I said that I can fill this circle with all these 3 values, that is, either with 9 or with 10 or with 11. Similarly, I can fill this circle either with 7 or with 3 or with 2 or with 1. So if you select any value from this and any value from this one at a time, then it will always satisfy this condition, right? So suppose I selected 9 from here and 7 from here. So if I select 9 here and 7 here, then 9 is greater than 8 and 8 is greater than 7. So this is a valid triplet. So we will increase our count by 1. Similarly, if we select this 9 and this 3, that is 9 and 3, then again 9 is greater than 8 and 8 is greater than 3. So again we will increase plus 1 to our answer. That is, it is a valid triplet, right? Similarly, if we select this 9 and this 2 like this, then clearly the value is decreasing while going this way, right? So again a valid triplet. Similarly, if we select this 9 and this 1, that is this, so again it is decreasing while going in this way, so again a valid triplet. Now if we take 10 from here and 7 from here, that is this, then clearly 10 is greater than 8 and 8 is greater than 7, so again a valid triplet. Similarly, if we take this 10 and this 3 like this, then again the value is decreasing and again plus 1. Similarly, if we take this 10 and this 2 like this, so again the value is decreasing, that is 10 is greater than 8 and 8 is greater than 2, so plus 1 to our answer. And similarly, if we take this 10 and this 1 like this, then again the value is decreasing, so again plus 1. And now if we take this 11 from here and 7 from here, that is this, so clearly 11 is greater than 8 and 8 is greater than 7, so plus 1. Similarly, if we take 11 from here and 3 from here, so 11 is greater than 8 and 8 is greater than 3, so again plus 1. Similarly, if we take 11 from here and 2 from here, so 11 is greater than 8 and 8 is greater than 2. And at last, if we take this 11 and this 1, that is this. So clearly 11 is greater than 8 and 8 is greater than 1. So again plus 1 to our result. That is, we got a total of how many triplets? So we got the first triplet by the combination of this, this and this. The second triplet by the combination of this, this and this. The third triplet by the combination of this, this and this. And the fourth triplet by the combination of this, this and this. And same for these. Right. So if I try to write it mathematically, then how many triplets I am getting? So I will say that the total triplets, that is I, j and k, right, possible for a given jth index is equal to nothing but the number of elements present on its left, right, and they have to be greater than the jth index element into the number of elements present on the right side which are less than this jth index element. So since here the number of elements greater than 8 on its left side was 3 and the number of elements smaller than 8 on its right side was 4. So I will say here 3 into 4, right? So 3 into 4, that is 12. So it means that by keeping this 8 fixed here, that is this third index, so this is my jth index, right? So by keeping this third index fixed here, I can generate a total of 12 triplets as we just saw. And since we want to do this for each and every index of this original array, it will ultimately give our result that we wanted to compute. For each of these indexes present in the original array, that is these, right? So one by one, we will consider them as the jth index and will keep fixing them one by one, right? And just add this result to our answer for each of these fixed index. Because we saw that whenever we fixed some index and computed the number of elements greater than this fixed index on its left side and the number of elements smaller than this fixed index on its right side, and we just multiplied them in order to compute the total number of triplets possible for this j, right? So it was 12 here. So since it was 12 here for this jth index, that is the third index here, so in the same way we will fix each and every index one by one and we'll compute the same thing and we'll just add it to our final result. So since now I did it for this third index, what I am now telling you is to do is we want to fix it for each and every index. But there is a very one good thing to notice. You can never fix this 0 or this 7. Why? Because there is no element present on its left side. And similarly, there is no element present on the right side of the 7th index, right? So it is not useful to determine the number of greater elements on this left side. And similarly, it is not useful to determine the number of smaller elements on this right side. And whenever we will fix some index, we will just compute the number of elements present on its left side which are greater than the current element, and the number of elements present on its right side which are smaller than the current element. And if we multiply these two, that is we take all the possible combinations, then that will give us the total number of triplets possible for that jth index. So if I write that down here, so for these 3 we got 12, right? So if I do the same thing one by one, that is keeping each of these indexes fixed. So let me do this thing quickly so that you can understand this thing in very much detail. So let us now start fixing them one by one. So now I am trying to fix this one index here, right? So what is the value of this first index? It is 10. So now I want to find the number of elements greater than 10 on its left side. So since this is the only element present on its left and is greater than 10, so I can write here that there is a total of one element present on its left which is greater, which is 11. Similarly, if I want to find the number of elements which are smaller than this 10 on its right side, so how many elements are smaller than 10? So if you look, then all of these elements are actually smaller than 10. That is a total of 6 elements, right? So I will write here 6. And if I write down all the elements also, then they are like 9, 8, 7, 3, 2, 1, right? So this is for the left side and this is for the right part. And now if we multiply these two terms in order to get the total number of triplets possible for this jth index, that is this first index, then it will be equal to this 1 into 6. So 1 into 6, which is 6. So I will write here 6. So a total of 6 triplets are possible. So it will be what? So it will be either 11, 10 or 9 or 11, 10 or 8 or 11, 10 or 7 or 3 or 2 or 1. So that's why a total of 6 triplets possible. So I wrote here 6. Now I want to compute for this index. That is the second index. So what is the value? The value is 9. So now I want to answer the number of elements present on its left which are greater than this 9. So since there are 2 elements which are greater, so I will write here 2. And what are these 2 elements? These are 10 and 11. Similarly, I want to find the number of elements in this range which is smaller than this 9. So since each of these elements are smaller than 9, so I will write here 5. And what are they? They are 8, 7, 3, 2, 1. So in this part there are 2 elements and in this part there are 5 elements. So if I multiply this 2 into 5, we will get 10. And hence I will write here 10. So now we are standing at this 4th index, which has a value of 7. So now I want to find the number of elements greater than 7 on its left. So clearly there are 4 elements which are greater than 7, right? So I will write here. And what are these 4 elements? These are 8, 9, 10 and 11. So 8, 9, 10 and 11. So this is my left part. And now I want you to answer the number of elements present on its right side which are smaller than this 7. Since all these 3 elements are actually smaller than this 7, so I will say a total of 3 elements are actually smaller, which are 3, 2 and 1. So this is my right part. So the number of triplets possible by keeping this 4th index fixed here will be equal to this 4 into this 3. So now I am standing on the 5th index, which has a value of 3. So now, what is the total number of elements greater than 3 on its left side? So all these 5 elements are greater. So I will write here 5. And what are these elements? These are like 11, 10, 9, 8, 7. So this is my left part. Similarly, I want to find the number of elements smaller than 3 on its right part. That is this part. So since both of these are actually smaller than 3, so I will write here actually 2 elements which are 2 and 1. So this is my right part. And if I want to compute the number of triplets, then they would be like 11, 3 and 2, 11, 3 and 1, or either 10, 3 and 2, 10, 3, 1, and same for these, right? Which would be total equal to this 5 into these 2, that is all the combinations, so 10. So I will write here 10. So now I am standing at this index which has a value of 2, right? So this has a value of 2, and now I want to find the number of elements greater than 2 on its left. So I think each of these elements are actually greater than 2, right? That is 6 elements. So I will write here 6, and they are like 11, 10, 9, 8, 7, 3. So this is my left part. And the number of elements smaller than 2 on its right is just 1. So I will write here 1 element only, which is 1 only. So this is my right part. And the number of triplets possible in this case will be equal to 6 into 1, which is 6. And also I told you in the beginning that no triplet for the starting index and the ending index will be possible, because they can never be our jth index. Why? Because there is no element present on its left side. So there is no a of I present, that is this, which will be actually greater than this 11. Similarly, there is no a of k present on this side, which will be less than this. So that's why 0 for these two. And once we have found these values, we just have to add that, right? So what will be the summation of all of these values? So it will be equal to 56 only. So that means a total of 56 triplets are possible for this given array. So we will just return this 56. So I really hope by now you must have understood what we want to calculate, right? And what will be our logic. So now we just have to find these two things for each index, right? So we have already discussed how to find this term, that is the number of elements greater than the current element on its left side, in the first video of this series, right? So this is the exactly same thing, and as I told you that this is nothing but the reversed version of this. That is, instead of going in this direction and calculating this, if we go in this direction, then we'll get this, right? and it depends on us, like if you want to either calculate the greater element or the smaller element on its left, or the smaller element or the greater element on its right. So we can decide this at any time, so this is not an issue. So what we used to do, if you remember, in order to find this, we used to take the maximum element of it, which is 11 here, and used to draw another array such that we can access the 11th index easily, right? And whenever we used to do a transition from one index to another index, we used to update this thing continuously and just take the range sum in order to either find the greater or the smaller element present on its left side. So this is not an issue at all, right? I want to compute this term now. So consider this whole structure here. As I said, for the given array, since our 11th element is the maximum, so I drew this another array such that I can access this 11th element easily, right? And using this array, I will just find the number of elements greater than the current element on its left. Exactly same as in the first video. What we used to do, if you remember in this case, so initially the value of each and every element in this array used to be 0, right? We always start from the first index and go till the 6th index, because for this 0th index there is no element present on its left side which is greater. And similarly for this 7th index, that is this one, there is no element present on its right side which is smaller. So whenever we do a transition, we used to update the status of this in this array, right? So since I am moving from 0 to 1, I will update this in this array. So this 11 will now become equal to 1. That is, if now I am standing on the first index, then I have encountered 11 a total of 1 time before. So this array represents the status of the frequency of the elements that I have encountered before. Okay. And now, since we also want to calculate this term simultaneously, so how we will do this? As of now, I am standing on the first index, right? And for this first index, I know the value of this term by taking the range sum of this, which is 1 here. So I know that a total of 1 element is present on its left side, which is greater than 10. So I already know this using this array. But now the question is how we will determine this term using this array. That is, for each index we want to determine the number of elements smaller than it on its right side. So if I am standing on this particular index, then I only want the information regarding this range, right? Because if I am standing on this index, then I am assuming that I have started moving in this direction and currently I am standing on this index. So I should not have this information, right? I only want this information and want to determine out of this range the number of elements greater than or less than, right? So let me tell you again what I just said. So if I am standing on this index and want to find the number of elements greater than or smaller than on its right side, then only this much information I need in this array. I don't need this information, right? So you can think it like I have not yet encountered these elements. I have only encountered these much elements while moving in this direction. If I am standing at the 0th index, then what will be the status of this array? I would not have encountered any element before, right? If I have not encountered any element before, it means that the value of each and every element in this array should be 0. And also, if I am standing on the 0th index, then what does it mean for this array? It means that I have started my journey from here, right? And reached this 0th index. So by doing this, I have already encountered these elements one time. So that's why I can say that the value of each and every element present in the original array in this array will be equal to 1. We started moving in this direction from the right side, right? And if we are standing at the 0th index, then it meant for this array that we have not yet encountered any element. So it was 0 for all. But since we are standing at the 0th index, that is, we have started moving in this direction and reached this index, so it means that we have already encountered each and every element once. That's why I will write here the frequency for these terms like 1, 2, 3, 7. So 1, 2, 3, 7, and then 8, 9, 10 and 11. So 8, 9, 10 and 11 equal to 1, and others will be 0 only. So this will be the status of our second array initially. And since I did a transition from the 0th index to this first index now, it means that I only now need the information for this range, right? Because if I am standing on the first index, then in this way I only have reached the first index from the second array's perspective, right? So the only elements that should be updated in this array should be these ones only, right? So that's why what I will say is I will decrease the count of this 11 here by 1. So this 11 will now become equal to 0. I hope you have got this concept. So if I am standing on this index, then I only need the information for this range, right? You can also take it for this range, there is no problem. So now we are standing on the first index, and this is the status of our first array. That is, we have encountered 11 a total of 1 time, and we have also encountered these much elements while moving in this direction, which is obvious from this array, right? So now if we want to compute the total number of elements smaller than the current element on the right of this first index, that is the total number of elements smaller than 10 in this range, then what we will do, since we want less than 10, that is less than or equal to 9, so we will simply take the range sum from 0 to 9 like this. So what is this equal to? So it is equal to 6, and if you see, then there are total of 6 elements which are actually smaller than the current element. So that's why we will easily get 6 from this array. So since we got 1 from this array by taking the range sum of this, and 6 by taking the range sum of this from this array, so 1 into 6, which is equal to 6, which we got earlier also. Now let us move to the second index. So now we are standing on the second index, and when we did a transition from 1 to 2, we have to make sure that we have to include this count of 10 here. That is, the value of this 10 now will increase to 1. Similarly, we also have to make sure that we don't need this information anymore in this array, right? Because if we are standing at this index, then it means that we have traversed in this direction and reached this index. So we only need the information of this part and not this part. So that's why we have to decrease the count of this 10 in this array. So just decrease this 1 to 0. And now let's compute these two terms. Now I want to compute the number of elements greater than 9, that is greater than or equal to 10. So if you take the range sum here, it is equal to 2. So we are getting 2 from here. And also I want to calculate the number of elements less than 9, that is less than or equal to 8 in this range, right? So if we take the range sum from 0 to 8, so it is equal to 5 only. So I am getting 2 from here and 5 from here, right? So 2 into 5, 10, which we got earlier too. And now if I move to the next index, so I am standing here, and since I did a transition, I have to make sure that this 9 is included in this array, right? Because we have encountered this 9 once, so this would be 1. Similarly, since I am standing on this index, it means that I only need the information of this and not this, because when I had traversed till the third index, I would have only encountered these much number of elements and not these. So the status of this should be absent from this array. So that's why I will decrease the count of this 9 from 1 to 0. And now if I compute these two terms, so the number of elements greater than 8 on its left is actually 3, right? It is obvious from the range sum here also. So 3 from here. And we have to multiply this 3 with the number of elements smaller on the right of this 8. That is less than 8, which is less than or equal to 7. So if I take the range sum from 0 to 7 here in this range, so it is equal to 4 only, right? So 3 into 4, which is 12. So 12, just as we got before. Now we are standing at the fourth index, and we did a transition from 3. So let us update the status of this 8 in both of these arrays. So this 8 will now become equal to 1, because we encountered it. And since we want to lower the information in the second array, so I will say that for the 8th index, it is 0 now. So this information is not needed now. We only need this information, because if you are standing at this index, then I am assuming that we have traveled in this direction hypothetically. And if I have traveled in this direction and reached this index, then I would have only encountered these much number of elements and not these. So these status should be absent from the current array. So now what I want, the number of elements greater than 7, that is greater than or equal to 8. That is the range sum of this, which is 4 only. So 4 from here into the number of elements smaller on the right. So smaller than 7, that is smaller than or less than or equal to 6, right? So the range sum of this would give us this, which is 3, which is true here also, right? So 3 from here. So 4 into 3, 12, just as we got before. And now if you move forward, then we should be standing at the 5th index. And since we encountered this 7 here at the 4th index, update in both the arrays. So increase the count of this 7 here by 1 and lower the count of this 7 here by 1. And now again compute these two terms. Number of elements on its left greater than 3, that is greater than or equal to 4. That is the range sum of this part, which is equal to 5 here. So I am getting 5 from here. That is 5 elements actually greater than 3 on its left. Similarly, the number of elements on its right which are less than the current element, that is less than 3, that is less than or equal to 2. That is the range sum of this, which is actually 2 only. So 2 from here, that is 5 into 2, which is 10. So that's why 10 here is the output that we got before. And now let us move to the next index. So now I have moved to the 6th index, and since I did a transition, let's update the status of this 3 here in both of these arrays. So this 3 now should become equal to what? So here the 3 will be equal to 1 and here the 3 will be equal to 0. And now let's again compute these two terms. So now I want the number of elements greater than 2, that is greater than or equal to 3. That is this range sum, which is equal to 6 only. So 6 from this side, and the number of elements less than the current element on its right, that is less than 2, that is less than equal to 1. So this range sum, which is 1 here. So 6 into 1, that is 6. So this is the output that we got before. And now we will stop at this point. We don't need to go any further, because as I said before that, we already know the answer of the last index and the first index, which is 0. So now I am so sure that you must have understood how this solution is working, right? So I think it would be better for us if we actually move to the VS Code editor and actually code this up. Then it will be very clear to you how actually everything is working under the hood. So let us now go to the code editor and code this up quickly. So first we have to take the input for the number of integers. So I will use long in every place, right? So keep this in mind. So just take the input for the number of integers, and then so let me declare the vector here also. And as I told you in the explanation that we want the maximum value of the array, right, in order to construct the segment tree array. So we will do this here only. So I will say that initially maxi is 0, and while calculating the input here, I will simply calculate my maxi here also. So maxi equal to max of maxi comma this num psi, like this. So once we have done this, and also take this as long only, right? So once we have done this, I will declare my actually segment tree here. So I will use this first segment tree in order to calculate the number of elements greater than the current element present on the left side. So let me name this as the forward segment tree array here, like this. And similarly, I can construct another segment tree that will give me the number of total elements smaller than the current element on its right side, like this. Let me copy my standard segment tree template here. So this is my standard segment tree template here that supports mainly two operations. First is the point update, and the second is the range sum. And keep one thing in mind, that in this point update actually I am increasing the delta. That is, I am not setting it equal to delta, actually I am increasing the delta. So if this delta is +1, it will actually increase the count, and if this delta is -1, it will actually decrease my count. And instead of passing this array here, I can simply pass the maxi that I have calculated, because we don't need to pass the actual array here, because if we pass this maxi here only, then we know that if the maximum element present in the given array was 11, then we want to access the 11th index, right? So that's why in order to access this 11th index, I am increasing my maxi by +1 here, so that whenever I set the index of size of the segment tree, I can easily access this 11th index. So that's why I am doing a maxi ++ here and setting the size of this segment tree equal to this maxi. And once I do this, I am just assigning the value of each and every element in this segment tree equal to 0. That is, after writing these two lines, what will happen? It will construct these two arrays, but with each and every element equal to 0, right? So initially each and every element will be 0 for this and for this also, right? So the same thing is done here also, right? and then the usual build query update functions. As I told you that before actually starting our range operation, we have to set the status for each and every element given in the original array equal to 1 in this second array, right? And not each and every index. We just have to update these given elements position. So since these terms like 4 and 5 was not present in this array initially, so we will not consider them equal to 1 here, right? So that's why we will set equal to 1 only those elements which are present here initially. That is, we have encountered them only and not the others. So we'll write the same thing here. That is, we'll travel each and every element again. I have to update the second array. That is backward.update. Position we have to update the nums of I equal to 1. That is, the value of delta is 1 here. So since it is plus 1, it will increase the count of all of these positions by 1. And now what we used to do, if you remember, so we used to travel from the starting till the end. That is, our j will go from the starting till the n-1, and for each of these j, we used to calculate the number of elements which are greater than the current element on its left. And this is calculated using the first array, that is forward.query. And since I want the greater, so I will say nums of j plus 1 till the last element of this array, that is this. And in the same fashion, I also calculate the number of smaller elements present on the right side, that is backward.query. And since I want smaller elements, so I will start from 1 and I will go till this nums of j minus 1 like this. And I just have to multiply these two terms and add it to our final result. So let me copy this here. So this will be my greater left and this will be my smaller right. And once this is done, and what we used to do after this, we used to make sure that before moving on to the next index, we have to update the status of the current indexes in both of the arrays. So I will say forward.update this nums of j by 1, and similarly this backward.update this nums of j by minus 1. So this plus 1 is the, so this one represents a plus 1 delta, that is we have encountered this element, and this minus 1 represents that we are erasing the information for this element. And why we are doing this, I told you very well in the explanation. And once we do this, we just have to print the final count value and then finally return. So I think I have written the complete code here. So if I run this, let's see if this is giving the correct output or not. So as you can see, each and every test case is getting passed very well, right? So I think I have written the correct code here completely. And also make sure that this int is actually long, so this can give wrong results. And I also have made sure that since I have used long in every variable here, so that's why I also made this segment tree with this long only, right? So now I think I have written the complete code, and now if I try to submit this on the platform, let's see if this is correct or not. As you can see here that we have got memory limit exceeded on test 21. So why this has happened? So the video is not over yet. Please be with me for some few more time. So if you have read the question, then notice one thing, that the value of each element can go up till 1e9. So if it goes till 1e9, then what will happen? This maxi will be 1e9, right? And if this maxi will be 1e9, then this maxi is equal to n here, and the segment tree size will thereby equal to 4n, that is 4 into 1e9. And we are using two such segment trees here, that is 4 into 1e9 twice. So that's why this is giving a memory limit exceeded. So let me tell you about this concept of coordinate compression here that will be used in this problem in order to solve this memory limit exceeded problem. So what we do in this? So suppose initially we were given this array, and when we tried to submit the solution for this input, we got MLE, right? Just assume this was our original given array. So how can we optimize this now using this coordinate compression technique? So what does this technique says? It says that, let me write the indexes here. So this is 0, this is 1, this is 2, and this is 3, right? So this technique says that initially what we will do, we will copy this original array into some other array. Let's say copy V. So we will copy this same array, right? So once I have copied this array, what we have to do next? We have to sort this copy array. So if I sort this, I will get this, right? And once I get this, the next step of this technique is to remove the duplicate elements. So since this 1e9 is coming twice, so I will say that in the next step, I will just remove one of them. So I will remove this last one. So this is my current status. And now this is my 0th index, this is my first index, and this is my second index. So it means that instead of using this 2e8 value, I will simply use this 0 value because this is unique for this 2e8. Similarly, instead of using this 5e8 value, I will use this 1 value. And similarly, instead of using this 1e9 value, I will simply use this 2 value. So this, you can think it like this 0 represents this 1 represents this now, and this 2 represents this now. So keep this in mind. So since the original array was something like this, so now if I map them using their new values, then it would be something like this 1e9 is now equal to this 2. So I will write 2. This 2e8 is now equal to this 0. So 0. Again this 1e9 is equal to this 2 only. So 2. And this 5e8 is now equal to 1. So 1. Instead of doing operations on this original array, that is this one, I will simply use this array now. And there is a very good thing to notice if you see clearly. So this was the biggest, then this, and then this. So in this array also if you see, then this is the biggest, this is the medium one, and this is the smallest. So the relative order of the ascending and descending order is same in this array as this array. And since we just wanted to compute the number of a smaller and greater on the left and right, we can just use this array instead of this original array, and this will not give me the memory limit exceeded that we just got. So that's why we will use this coordinate compression technique in this question in order to reduce these large values into these smaller values while keeping the relative order of the ascending and descending order same, and thereby playing with this array only in order to compute the greater left and the smaller right, and we'll get the exact results therefore. So now we don't have to calculate this maxi. Instead I will say that after taking the input, I will make another copy of this array as I told you. Let's name it as copy of v, and it will be equal to, or maybe copy of nums, so it will be equal to this nums only. And after doing this, we just have to sort this array, right? So I will sort this. So I will say sort. So after sorting it, what I told next, we have to remove the duplicates, right? So in order to remove the duplicates, I will say, so by writing this statement, it will actually remove the duplicate elements from this copy nums array, right? And after doing this, what we will do next? So I told you that for each of the original elements in the array, that is from 0 to n-1, we will assign new values. This nums of I will now be equal to what? So this lower bound function is used to find the new index in the uniquely sorted array. That is the copy nums array, right? And thereby assigning it to the original array like this. And once this is done, what I told you that my new maxi will be what? My new maxi will be the maximum element present in this nums now. So you can write it like, so this will be my new maximum element, right? So once we have written this and calculated our new maxi, I think the code is correct. But since now in the original question it was given that each and every input element was a positive integer, that is from 1 to 1e9, but since now the element's value can be 0 also, so I will say here that instead of starting from 1, I will actually start from 0. And now if I run the code, let's see. So as you can see that each and every test case is correct now, and I think now that it should not give the memory limit exceeded problem, right? So now if I try to submit, let's see if this is correct or not. So as you can see that it is accepted now, and this is the code that we just wrote. So the standard segment tree template, and initially we tried to do this with the coordinate compression, but then we saw that it was giving memory limit exceeded. And why, I told you very well, because the segment tree size was getting excessive. So that's why we apply this coordinate compression technique here, and I also explained you this technique, how this works, right? And then the rest everything as I just explained you in the video. So thank you so much for watching this video till this point. And if you have not subscribed to this channel, please subscribe this channel, because it is already creating a lot of amazing content here, right? And I'm so sure that these videos will definitely help you in your interviews, because the questions that I'm discussing here are really of good quality and obviously high rated. So consider subscribing the channel and share it with your friends who need it to watch the videos. So yeah, thank you for watching these videos. Thank you.